Questions 11 through 20 of the 2001 Grade 7 Gauss Math Contest. A fair die is constructed by labeling the faces of a wooden cube with the numbers 1, 1, 1, 2, 3, and 3. If this die is rolled once, the probability of rolling an odd number is. Alright, so normally dies have 1, 2, 3, 4, 5, 6, but this time they've given 6 different numbers. And you roll the die, and they're saying, what's the probability of getting an odd number? Well, our numbers are 1, 1, 1, 2, 3, and 3. If you roll this, the odd numbers are right here. 1 is odd, 3 is odd. So of the 6 numbers, 5 are odd. So this is basically the probability that if you roll the die once, you get an odd number. It's really that straightforward. So 5 out of 6. So therefore 11, the answer is A. The ratio of the number of big dogs to the number of small dogs at a pet show is 3 to 17. There are 80 dogs in total at this pet show. How many big dogs are there? So B over S, big dog over small dog, is 3 over 17. That's the first thing that we know from the question STEM. But the total number of dogs is 80. So we've got 2 equations, 2 variables we can now solve. I'll isolate for S in this question, or in this equation. So we've got B is equal to 80 minus S, or whichever way you want to do it, S is equal to 80 minus B. Since we're solving for B, big dogs, I'll put this one into this equation. So that becomes B over 80 minus B is equal to 3 over 17. Cross multiply and you get 17B is equal to 240 minus 3B. And therefore, if you bring the 3B over, it becomes 20B. Divide both sides by 20, and this gets you 240 over 20, and therefore B is equal to 12. So there's 12 big dogs. So the answer to number 12 is A. The product of 2 whole numbers is 24. The smallest possible sum of these 2 numbers is. So you have 2 numbers, A and B, and when you multiply them, it's 24. What they're saying is, what is the smallest you can make A plus B? All right, so let's make a little table. A times B and A plus B, like that. So A times B is always going to be 24. So how can I make 2 numbers that are whole numbers become 24? I can choose 1 and 24, 2 and 12, let's see, 3 and 8, 4 and 6, 6 and 4, and everything else will be the same as what I wrote. So 8 and 3 is the same as that, 12 and 2 is the same as that, 24 and 1 is the same as that. So now let's figure out the sum. This will be 1 plus 24, which is 25, 2 plus 12, which is 14, 3 plus 8, which is 11, 4 plus 6, which is 10, and 6 plus 4 is also 10. Well, this is the same as that, so I really didn't need to write this one, but that's fine. No big deal. So which of these sums is the smallest? And that would be this one right here. So the smallest possible sum of those 2 numbers is 10. So the answer to number 13 is B. In the square shown, the numbers in each row, column, and diagonal multiply to give the same result. The sum of the 2 missing numbers is. Okay, so first of all, let's figure out what is that result. And we can use any of these columns or rows. How about use this one here? So that result is 12 times 1 times 18, which is 216. So all of these rows, columns, and diagonals, the numbers in them multiply to give 216. So let's say this is x and this is y. So if we concentrate on that column, we will see that 12 times 9 times x must equal 216. So if you solve for x, you get 216 over 12 times 9. And this is equal to 2. So x is equal to 2. And in a very similar way, we solve for y using this column. 1 times 6 times y will be equal to 216. And therefore y is equal to 216 over 6, which is 36. So y is 36. So they want us to find the sum of the two numbers that are missing. So those two numbers are x plus y, which is 2, and 36, which is equal to 38. So the answer to number 14 is D. A prime number is called superprime if doubling it and then subtracting 1 results in another prime number. The number of superprimes less than 15 is... Okay, let's list the numbers that are between 1 and 15, less than 15. So I guess they only want us to go up to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right? Now, let's circle which one of these, first of all, is a prime. Okay, 2 is a prime, 3 is a prime, 5, 7, 11, and 13. 1 is not a prime. 1 is not a prime number. Say it again. Say it a million times. You have no idea how many students will get a question like this wrong because they think that 1 is a prime. 1 is not a prime. If you don't believe me, verify it on Google. I am emphasizing that fact for a reason. 1 is not a prime, so please remember that. So, we've circled the prime numbers. Now let's talk about the superprime. It is a superprime if you double the number and then subtract 1. So for each of these, we're going to do that. We're going to double it and then subtract 1. So 2, if you double 2 and subtract 1, you get 2 times 2, which is 4. Minus 1 is 3. Let's do the same thing for the next one. Double it and then subtract 1. So 2 times 3 is 6. Subtract 1, 5. So let's do this for all the primes. Double it, 10. Subtract 1, 9. Double it, 14. Subtract 1, 13. Double 11, you get 22. Subtract 1 gives you 21. And finally, double 13, 26. Subtract 1, 25. Now, of these, which one is a prime? This is a prime, this is a prime, this is not. This is a prime, this is not, and that's not. So only 3 of the numbers that were less than 15 are superprime. So the answer to number 15 is B. BC is a diameter of the circle with center O and radius 5, as shown. If A lies on the circle and AO is perpendicular to BC, the area of ABC is. So let's start labeling this. They've told you that the radius is 5, and therefore from here to here is 5. But from here to here is also the radius, right? AO, and that is 5. And OB is also 5 because that's also the radius. So from B to C, this whole region, which is the diameter basically, is 10. So how do you figure out the area of a triangle? 1/2 base times height. So in triangle ABC, we have 1/2 base, which is from here to here, which is 10. And then the height is from there to there, which is 5. So this looks like 50 divided by 2, which is 25. And therefore the answer to 16 is C. A rectangular sign has dimensions 9 by 16. has a square advertisement painted on it. The border around the square is required to be at least 1.5 meters wide. The area of the largest square advertisement that can be painted on the sign is. All right, so we've got this billboard or whatever, and they're going to put inside a square. So the square has to be something like this. All right. Now, don't worry about being drawn to scale. Just, I hope you understand the question. So it's 16 by 9. That's the dimensions of that rectangular sign. And once they make the square, they have this criteria that the square and the border of the sign, the rectangular sign, this distance from here to here has to be at least 1.5 meters. So this has to be 1.5 meters. All right? So therefore, from here to here, it's got to be 9 minus 2 times 1.5, right? Because you're subtracting 1.5 from top and you're subtracting 1.5 from the bottom. And this whole thing is 9. So that means the side of the square is 2 minus 3, 9 minus 3, which is 6. So that means basically that the side of the square is equal to 6. And they want you to figure out the area of that square. Well, the area of a square is just the side times itself. And our side we figured out was 6. So 6 squared is the area of the square, which is 36. And therefore the answer to number 17 is C. Felix converted $924 to francs before his trip to France. At that time, each franc was worth 30 cents. If he returned from his trip with 21 francs, how many francs did he spend? So let's first create the mathematical equation. We have $924, and that over a certain number of francs, we don't know yet, is equal to our exchange rate, which is $0.330 over 1 franc. So this is our exchange rate, and I've just incorporated that into the question STEM information. So we can solve for this. 924 over x is equal to 0.3 over 1. Cross multiply and you get 924 is equal to 0.3x, and therefore x is equal to 924 divided by 0.3, and x is 3,080. 3,080 what? Francs. So when Felix goes on this trip, he takes with him 3,080 francs. When he comes back, he's only got 21 francs left. So they want you to figure out how many did he spend. Well, he went there with 3,080, came back with 21. So 3,080 minus 21 is 3,059. That's how much he spent. And therefore the answer to number 18 is D. Rectangular tiles. Rectangular tiles which measure 6 by 4 are arranged without overlapping to create a square. The minimum number of these tiles needed to make a square is. So we've got these rectangular tiles and they're 6 by 4, and we want to basically put them together to make a square. So if you make a square, the length of the square and the width of the square have to be the same. So how can we do this? And I'm going to draw what I believe is one possible way, and that's if you arrange the rectangles like that. Now we've got 6 by 4, correct, as the dimensions of each tile. So that's 6, that's 4, this is 4, and this is 4. If you arrange it in this way, this side all becomes 12, and this side all becomes 12, and therefore it becomes a square. And in that kind of arrangement, the requirements of the question are satisfied. So how many tiles were needed to make that square? Well, there were 6 of them. So the answer to number 19 is E. And Beth and Chris have 10 candies to divide among themselves. Anne gets at least 3 candies, while Beth and Chris get at least 2. If Chris gets at most 3, the number of candies that Beth could get is. All right, so Anne, Beth, and Chris. And A plus B plus C is equal to 10. Each of them gets a certain amount, but the total is 10. So they've given us a criteria. Anne gets at least 3. So she has to get at least 3. So the number she gets is greater than or equal to 3. B, which is Beth, gets at least 2. And Chris gets at least 2. But Chris gets at most 3. So the most he can get is 3. So they've given you a boundary for Chris. And they're trying to figure out now how many can Beth get. What are the possible scenarios for Beth? All right, so let's work with this. First scenario for our question involves C equal to 2. Because C, if you look at this, there's only 2 possible values, 2 or 3. That's it. So let's look at C equals 2 first. If C equals 2, A plus B plus C is equal to 10. A plus B plus 2 is equal to 10, and therefore A plus B is equal to 8. So using our boundaries here, A can be 3, 4, 5, 6, and if therefore A is 3, B in this question will be 5, 4, 3, and 2. We can't go any lower than 2 because B is greater than 2, greater than or equal to. So using C equals 2, I found these values for B, 2, 3, 4, or 5, which is answer E. But let's complete this question by figuring out what happens when C is equal to 3 from here. If C equals 3, we have A plus B plus C is equal to 10. A plus B plus 3 is equal to 10. Therefore, A plus B is equal to 7. So now if we make a list for A and B, we'll have, let's see, 3, 4, and 5 for A as possible choices. If A is 3, B would be 4. If A is 4, B would be 3. And if A is 5, B would be 2. Can't go any lower than 2 because B has a condition. It's greater than or equal to 2. So in this scenario, B can be 2, 3, or 4, which essentially is the same as what we got in the first case. So the total number of possibilities are right here. B can be either 2, 3, 4, or 5, so E was indeed correct for number 20.